G'day folks, I just wanted to put up an introduction to probability, which at KHS we do in 5.3, we do all of stage 5 in year 9. So we're going to look at some work from both the year 9 and the year 10 Cambridge textbooks in this course. We're just going to start off today, just going to dip our toes in. We've seen probability before. We first saw it in year 7 and it might have come up again even in year 8. Probability is basically the mathematics of likelihood. Now, it's not the mathematics of certitude. So if I talk about the probability of something, it doesn't mean that that's certainly what's going to come about. It just gives us a way to mathematically gauge the likelihood of that thing. So one of the advantages of probability is that probability only has one formula. For as far as I've gone into it, it always seems to me that probability comes back down to different ways of expressing that one formula. What makes probability hard, and this is going to sound strange to a lot of people, is that you need to be able to count. Now, I know that people go, Mr. Obeid, I can count. Look, nothing to worry about with me. You'd be surprised. Counting can be pretty difficult. So, for example, if I said to you, if I was to pick a number at random between 100 and 200, what would be the probability that it was a prime number? You'd need to be able to count the prime numbers between 100 and 200. Can you do that easily? It takes some work to come up with that. What about if I was to say, this is just a counting question in general, not necessarily a probability question. If I was to say there was a dad who had 7 children and he wanted to take all of them rowing. He's got a little rowboat and he wants to take all of his children rowing, but he can only safely take 2 children at a time. But every child wants to go rowing with every other one of their siblings. How many rowing trips is the father having to take out? It's a tough question, isn't it? A similar question, if there were 7, this is the same, mathematically it's the same question. If 7 people walked into a room and they all wanted they're all going to bump elbows, right, because nobody actually shakes hand anymore. Let's say they're all going to bump elbows. Right? So everyone's actually going to touch right elbows together. If 7 people want to do that exactly one time with everybody else in the room, how many elbow bumps are going to take place? Now, I'm sure you can work it out. You're clever enough to sit down and sort of scratch out some sort of answer to that. But it took some work, didn't it? Okay. So counting is what makes probability tricky. Let's lay down some foundations. Before we get into any of the hard counting problems, let's just lay down some basic foundations of probability. So there was only one formula, like I said. The probability of an event is the number of ways the event can happen divided by the number of elements in the sample space. Now, there was a lot of language in that, wasn't there? The probability of an event. So what's an event? Okay, well, if I say I've got a room with 5 girls and 4 boys in it, and I'm going to pick one person at random, completely at random. So I'm not going to look around and say, that girl looks like trouble, I'm going to avoid her, or that boy looks like trouble, I'm going to avoid him. If I'm going to pick completely at random, and I say, what's the probability that the person I pick is going to be a boy? So the event that I'm talking about, the probability of the event is picking a boy at random. Okay. The number of elements. Let's back up. Yep. So, the number of ways the event can happen. So, okay, if there's 5 boys in my room, if there's 4 boys in my room, sticking to that example, there's 4 boys in my room. Well, how many ways can I randomly pick one of those boys? Well, there's 4 different ways. I can pick boy A, boy B, boy C, or boy D. Okay. And then the sample space, the number of elements in the sample space is the number of total possible outcomes that I can have. So if I walk into a room with 9 people in it, 5 girls and 4 boys, Well, the total number of options I have for picking a person at random is 9. Okay, so let's write this formula out in words so we can sort of help understand a little bit better. So if we're going to do it with the sentence, we should start correctly. So the probability of an event is equal to the number of ways the event can happen divided by the number of possible outcomes. Okay, so the probability of an event is equal to the number of ways the event can happen divided by the number of possible outcomes that could have happened. Okay, so that leads us on to like a natural discussion of some of the language of probability. So probability is always going to be some kind of fraction. Now, there's different ways to express fractions. We can express them as fractions. We can convert fractions to decimals. We can express fractions as percentages as well. So, but in all of those cases, there are going to be things that are always true. Okay? So, the number of ways that my event can happen can never be bigger than the number of possible things that can happen. Right? So let's go back to our example: 5 girls, 4 boys in the room. And I say, look, what's the probability, if I'm going to pick somebody at random, what's the probability I pick a girl this time? Okay. Well, I can't say, well, there's 5 girls and 4 boys in the room, so that means there's 11 ways of picking a girl. No, there's not. There's only 5 of them in the room. So there's only one way for me to pick a girl from the room. The number of ways my event can happen can't be bigger than the total number of people in the room. So there's only 9 people in the room. There can't possibly be 11 ways of picking one of those people. Okay. So that means that a probability can never be greater than 1. The greatest probability that something can have is 1. So what's an example of something with a probability of 1? If I'm going to roll a die, just a standard 6-sided die, if I roll that, what's the probability that the number is going to be less than 10? Well, the number's certainly going to be less than 10. Right? Every number I can pick is going to be less than 10. Okay, so the number of ways I can get a number less than 10 on a standard die is 6. The number of possible things that can happen on a standard die is 6. So the probability of getting a number less than 10 on a standard die is 6 out of 6. It's going to be a probability of 1. Okay. What's something with a probability of 0? Well, let's reverse that around. If I'm going to roll a standard die, what's the probability I get a number greater than 8? Well, the standard die, the numbers are 1 to 6. How many possible ways can I get a number bigger than 8? 0. Out of how many possible things can occur? 6. 0 out of 6 is 6. So all probabilities have to fall within that range from 1 as our highest probability and 0 as our lowest. If you're doing a probability question, you end up with a probability that is more than 1 or more than 100% or more than 1 over 1, you've made a mistake. If you end up with anything that's a negative, less than 0, you've made a mistake. Probabilities, the probability of an event must lie between, it must be bigger than or equal to 0, and it must be less than or equal to 1. Okay, always true. Now we can attach some language to these things. So let's imagine that we had like a bit of a scale, where down here we had a 0 probability, and over here we had a probability of 1, or 0 and 100%, or 0 and 1 out of 1, or whatever. So we're going between 0 and 1. This is the maximum probability. This is the minimum probability. A probability of 0 in terms of our normal everyday speech, we'd attach the word impossible. Now, mathematicians don't, when we use words, they're always very precise. Sometimes they're just there to make us look smart, but they're never imprecise. Okay? So when we say impossible, we mean there is not a way where this thing is possible. It cannot be. Okay? We don't mean, how'd you go Powerball last night, did you win? Winning, that's impossible. Well, no, it's not impossible because somebody won. Okay, so impossible means there is no possibility. Okay? And our probability of 1 means that something is certain. Now, certain means certain. It means that it absolutely, infallibly, that it can't not happen. Okay. So, for example, rolling a die and getting a number less than 10. Well, it's impossible not to. It's certain you're going to get a number less than 10. So at the middle, at 0.5, we say we have an even chance. So it could go one way or the other. So the classic even chance example is flicking a coin. If I'm going to flick a coin, I've got an even chance of heads or tails. Okay, it could be one, could be the other, with just as much likelihood either way. If something is sort of up towards certain, then we talk about it as being likely or very likely. As it gets closer to 1. If it's less than an even chance, we talk about it being unlikely or very unlikely. Okay, so we've got that sort of scale for our language. And look, there's no number or what number is exactly does very unlikely kick in at, or what number does likely become very unlikely. So there's no actual number for that. We just use sort of general expressions. I know that I said mathematicians were very precise, but over here we basically are looking at sort of usage from everyday English to describe probabilities between impossible, even chance, and certain, and just so that we understand that there's this idea of a sliding scale. Okay, as a general rule of thumb, I'd call very likely things that were above a point, like a 0.8 or above, and likely sort of between 0.5 and 0.7, sort of in that kind of range. Okay? Again, down here, unlikely anything from below 0.5 down to about 0.3, and anything from 0.2 down to 0 as being, just above 0 as being very unlikely. That's as a general sort of rule of thumb. You're not going to get questions where you're going to be marked incorrectly. Or, look, you'll certainly never get a question where they give you a 0.75 and say, describe this. And if you pick the wrong word, or, do I say very or do I say likely? Do I say very likely or do I say likely? And if you get the wrong one, no one's going to punish you for that. Play it safe. Just say, look, it's likely. It's in the top half. Good chance it's going to happen. But yeah, so you're not going to be persecuted for an accidental use of very when it could have just been likely. Okay. Righto. So there's in the very first exercise of chapter 9, 9A, there's a lot of work on just because you need the skill of being able to convert fractions to decimals to percentages. It's a very basic skill for you guys. 5.3 mathematics in year 9. You can convert fractions to decimals to percentages. Don't sit there and think, oh no, Mr. Obeid said I need to be able to do it and I'm having trouble with it. I'm so embarrassed. If for any reason there's any kind of hole in the back line there, don't sweep it under the carpet. Let me know and I'll do an explanation. I always do them anonymously. I don't name anybody in those YouTube videos, so don't panic and think, oh no, the whole world's going to know that Jaden doesn't know, how to convert a half to a decimal. Okay, Jaden's perfectly safe. I'm not going to out him. Okay. So guys, I want you on page 533 to copy out the key ideas into your books, and then I want you to have a go at exercise 9A, and then I want you to let me know of any problems that you have either in the comments below down there or over on Microsoft Teams. Cheers guys, take it easy. Thanks. Bye-bye.